Start ArcGIS Pro and choose to create a new blank project. A default name and location are suggested, but wise users mindfully select appropriate names and locations for data. Name the project New Jersey and specify the GIS class Projects folder as the location to store it. Use Insert Project New Map to create a new map. Rename the map NJ Data. Use the Catalog Favorites tab to add the MGIS data folder to the project. Open the catalog view in the display area, not the catalog pane. Remember to use the contents pane, not the catalog pane, to navigate when in catalog view. Click the databases entry to see the home geodatabase, New Jersey. Click the folders entry to see the home folder, New Jersey, and the connection to the MGIS data folder just added. Double-click the MGIS data folder to see its contents. The data underneath is organized geographically. Open the Oregon folder and the Oregon Data Geodatabase. Choose Home, Options, Display Type, Tiles. Examine the data type beneath each dataset name. Explore the data in the MGIS data folder. Try to find an example of each data type listed in Table 5.1. In the Contents pane, click the Portal, All Portal entry. Type New Jersey in the Search Portal box and press Enter. Examine the different icons and the data type each represents. Try to find an example of a feature layer and a layer package. Click an item to view its metadata. Examine the metadata for several datasets, and note which appear professionally authored and which appear slapdash. The quality of the metadata is an important clue to the quality of the dataset. Switch to the NJ Data Map view and open the map properties for the NJ Data map. View the coordinate system settings. Type State Plane into the search box and click Enter. Expand the State Plane entry in the Projected Coordinate System folder. Scroll down and expand the Plane NAD 1983 meters entry. Do not choose ones labeled Course 96, PA 11, HARN, or anything else. Find the NAD 1983 State Plane, New Jersey, FIPS 2900 meters coordinate system. And click to select it. Also click the star to add it to your favorites. Click OK. Arrange the geoprocessing and catalog panes side by side. If both are currently in the same window, click the tab of one to separate it before docking it elsewhere. Make sure the catalog pane shows the Project tab with the local data. Expand the Folders entry to see the contents of the MGIS Data USA US Data GIA database. In the Geoprocessing pane, open the Feature Class to Feature Class tool. In the Catalog pane, find the States feature class in the US Data GIA database. Click and drag it to the Input Features box on the tool. In the tool, leave the output location set to the Home GIA database, New Jersey. Name the output feature class NJ Bound. Click Add Clause. Enter the expression state name is equal to New Jersey. Click the green check mark under the clause to verify the expression. Click Run to run the tool. The state of New Jersey appears on the map. In Contents, open the Layer Properties for the NJ Bound layer and examine the spatial reference entry in the source settings. In the Geoprocessing pane, open the Project tool. Set the input dataset to NJ Bound and name the output NJ Bound Gen. Set the output coordinate system. Since we set the map CS, we can simply choose Current Map NJ Data from the drop-down to set it to New Jersey State Plane. Run the tool. In the Catalog pane, expand Folders New Jersey, and then expand the New Jersey Home GIA database. Right-click the NJ Bound feature class and choose Delete. Click Yes to confirm. Open the Feature Class to Feature Class tool. From the Catalog pane, click and drag the Cities feature class from the US Data GIA database to the Input Features box on the tool. Leave the output location as the New Jersey Home GIA database. Name the output feature class NJ Cities. Click Add Clause and enter the expression state is equal to NJ. Near the top of the tool, click the Environments tab. Set the Output Coordinate System drop-down to Current Map NJ Data. Leave the other settings alone. Click the Parameters heading to return to the tool parameters. Run the tool. In Contents, open the Layer Properties for the new NJ Cities layer and examine the spatial reference in the source settings. The Feature Class to Feature Class tool is probably still open. Click the back arrow and reopen the tool to clear the current parameters. Set the input features to counties by dragging them from the Catalog pane. Name the output feature class NJ Counties. Enter the expression state name is equal to New Jersey. Click the Environments tab and set the Output Coordinate System to Current Map NJ data. Switch back to the Parameters tab and click Run. Click the Analysis, Geoprocessing, Environments button. Under the Output Coordinates, set the Output Coordinate System to Current Map NJ Data. Leave the other settings unchanged and click OK. Clear the Feature Class to Feature Class tool and reopen it. Export the CD114 feature class and save it as NJ Districts, selecting only the New Jersey districts. Check the output and make sure that it includes only the New Jersey districts and is stored in the State Plane Coordinate System. In the Catalog pane, expand the New Jersey GIA database to see the feature classes. In the Contents pane, view the layers that belong to the NJ data map. From the Catalog pane, drag the NJ Counties feature class into the map, making 2 NJ Counties layers. To help keep track, rename the new layer NJ Counties 2. Turn off all layers except NJ Counties, NJ Counties 2, and the base map. Change the color of NJ Counties 2. Note that the NJ County symbol stays the same. Open the layer properties for NJ Counties and examine the source, database, and feature class name. Make a note of it and close the window. Open the layer properties for NJ Counties 2 and compare the data sources. In Contents, right-click NJ Counties 2 and choose Label to turn the labels on. Turn NJ Counties 2 off and on to verify that NJ Counties has no labels. Both layers refer to the same location and same feature class in the home GIA database. Each layer presents a different view of the same data. In Contents, right-click the NJ Counties 2 layer and choose Remove. Auto-hide the Geoprocessing and Catalog panes to get more space if needed. Open the Catalog view in the display area. Navigate to the New Jersey GIA database and expose its contents. Click the NJ Cities feature class to view its metadata. Click the Home Metadata Edit button. An editing view opens for NJ Cities. In the description box, add this statement at the end. Subset to New Jersey from a national data set by your name on the current date. In the credits box, construct a citation to document the source of the data. Click Metadata, Manage Metadata, Save, and close the NJ Cities editing view. To update the thumbnail, click the Preview tab beneath the metadata. Click the Preview ribbon. Zoom or pan to adjust the view. And click Create Thumbnail. Return to the Metadata tab. If the new thumbnail does not immediately appear, click a different dataset and then return to NJ Cities. In the Catalog view, with NJ Cities selected, highlight the citation text and click Ctrl-C to copy it to save typing. In the Catalog View window, click the next item, NJ Counties. Click the Home Metadata Edit button to open the metadata for editing. Paste the citation into the credits box and edit the description as before. Save the edits and close the NJ Counties Metadata Editing view. Switch to Preview and update the thumbnail, as in Step 17. Then switch back to Metadata. Edit the metadata for the remaining items in the GIA database. You can use Word or Notepad to copy-paste the repeating text rather than typing it each time. When finished, leave the Catalog view open, but switch back to the NJ data map. Save the project. In the Contents pane, open the layer properties for the NJ Cities layer and examine the metadata settings. At the top, click the drop-down box and examine the two choices. The layer metadata can show the dataset metadata, the default, or it can contain separate metadata entered by the user just for this layer. Set the drop-down to Layer has its own metadata. All the boxes go blank. Enter some brief metadata items specific to New Jersey and the educational purpose of this dataset. Click OK. If you wish, unhide the Catalog and GIA processing panes so they remain open. In the Catalog pane, expand the Transportation Feature dataset in the U.S. Data GIA database to see the feature classes inside it. Drag the Madge Roads feature class into the NJ data map. In Contents, right-click the Madge Roads layer and choose Attribute Table. Examine the fields in the table and close it when finished. In the GIA processing pane, search for clip. Two clip tools appear, Clip Analysis Tools and Clip Data Management Tools. Hover over each clip tool and read the pop-up description. Open the Clip Analysis Tools tool and click on the circled question mark instead of hovering. The tool Help opens. Skim through it and examine the diagrams. In the Clip tool, set the input features to Madge Roads and the clip features to NJ districts. Name the output NJ Roads. Run the tool. Remove the original Madge Roads layer from the map. Zoom to the Stubby Peninsula of southeastern New Jersey and compare the NJ districts and NJ bound gen layers to the base map by turning them on and off. Zoom back to New Jersey. From the Catalog pane, click and drag the U.S. Data Quake/HIS feature class to the map. A few quakes do appear in the state. Search for and open the Select Layer by Attribute tool. Set the layer name to Quake/HIS. Click Add Clause to enter the expression state is equal to NJ. Run the tool. The selected features are highlighted on the map. In Contents, right-click the Quake/HIS layer and choose Data, Export Features. Set the input features to Quake/HIS and name the output NJ Quakes. Run the tool. Remove the Quake/HIS layer from the map. Save the project. Open the Catalog view and update the metadata for each new dataset. While still in Catalog view, examine the metadata for NJ-bound gen. In the Contents pane, showing the Catalog view, click the All Portal entry. Type Detailed States in the search box. Find the entry USA States, a layer package hosted by ESRI. Read the metadata and write down a citation for it. Right-click the listing for USA States and choose Add to NJ Data. Switch back to the NJ Data map. In Contents, expand the USA States group layer, which includes layers from several source scales. Click Map Selection, Select by Attributes. Set the layer name to USA States below 1 to 3M and enter an expression to select New Jersey. Export the USA States below 1 to 3M. And save it with the name NJ-bound DTL. In Catalog view, in Contents, view the New Jersey Geodatabase contents. Update the item description for NJ-bound DTL. And enter this citation in the credits box. In the Catalog view, right-click the NJ-bound Gen feature class and choose Delete. Click Yes. Switch back to the NJ data map and remove the USA states layer. Switch back to the catalog view and click the Folders entry in Contents. Right-click the New Jersey folder connection and choose New Folder. A new folder appears in the catalog view, ready to be named. Type the name Downloads and click Enter. Open a web browser and enter the search term New Jersey shapefile. Examine the results. Look for URLs that appear to be state-sponsored rather than commercial. For example, the Bureau of GIS State of NJ heading. Examine the site, which appears to be an excellent source of data for New Jersey. In the NJDEP GIS site in the web browser, find the golf courses data. And click to download. Save the zip file in the GIS Class Projects, New Jersey Downloads folder. Minimize. Do not close the web browser for a moment. Open File Explorer and navigate to the New Jersey Downloads folder. Use a zip utility to extract the files to the New Jersey Downloads folder. Close File Explorer. In Pro, open the NJ data map. Add the NJ Golf shapefile to the map from the Catalog pane. In Contents, right-click the NJ Golf layer and export the features to the New Jersey Home Geodatabase. Name the output NJ Golf. Review the dataset description on the website. Click the Metadata button for the golf courses dataset on the website. A view opens of the formal metadata in a format known as FGDC. Prepare a formal citation for this dataset. In Catalog View, click on the NJ Golf feature class in the New Jersey Geodatabase. A message about FGDC metadata appears. Choose Home Metadata Upgrade FGDC CSDGM content. Edit the metadata and add the citation to the credits section. Switch back to the NJ data map. In Contents, switch to the List by Data Sources panel. Remove any of the original sources that remain and ensure that all data in the map have their source in the New Jersey Home Geodatabase. Open the map properties for NJ data and examine the coordinate system settings. Expand the Layers folder and verify that all layers except the base map are in New Jersey state plane. Add the Climate Stations 2005 table from the MGIS Data USA folder. It contains longitude X and latitude Y locations of climate stations in the continental U.S. Open the table and examine the fields. In Contents, right-click the table and choose Display XY Data, which opens the XY Table to Point tool. Name the output feature class Climate Stations. Keep the X field set to long and the Y field set to lat. Click the Select Coordinate System button and select the GCS North American 1983 coordinate system. It should be in Favorites. Click Run. Remove the Climate Stations 2005 table. Use the Map, Selection, Select by Attributes button to select the New Jersey stations from the Climate Stations layer. Using the expression state is equal to NJ. Export the selected features to the home GIA database. Naming them NJ Climate Stations. Remove the Climate Stations layer from the map. Add the Store Openings.csv file from the MGIS Data USA folder. Open the table and examine it, particularly the address fields. Click Standalone Table, Data, Export, Export Table. Save it in the Project GIA database as All Walmarts. Open the All Walmarts table. Open the Select Layer by Attribute tool and select the New Jersey stores in the All Walmarts table using the expression str state is equal to NJ. Examine the bottom of the table to see how many rows were selected. It should read 41 of 3176 selected. Choose Standalone Table, Data, Export, Export Table, and save the output as NJ Walmarts. Open the NJ Walmarts table and confirm that it contains 41 rows and that all of them contain NJ in the str state field. Remove the All Walmarts and Store Openings.csv tables. Open the Geocode Addresses tool. Set the input table to NJ Walmarts. For the input address locator, choose ArcGIS World Geocoding Service. Set the address or place box to Street ADDR. Set the city to STR City and the zip to zip code. Name the output feature class NJ Walmart's PTS. Check the box for United States for the country. Click Run. It may take a few minutes to finish. Wait for it to display the new points on the map. Save the project. Choose Project, Open, and click your recent project BH Water Study to open it. Open the Study Quads map if it is not already open. Click Analysis, Geoprocessing Environments, and set the output coordinate system to match the current map. NAD 1983 UTM Zone 13N. Turn off all layers except the topographic base map. In the Catalog pane, expose the files in MGIS Data, Black Hills, Downloads. Add the Hill City structure and Mount Rushmore structure shapefiles to the map. Open the tables for both shapefiles and compare the fields. In the Geoprocessing pane, search for and open the Merge tool. Click the Input Datasets drop-down box and select Mount Rushmore structure. Click the second Input Datasets drop-down box and select Hill City structure. Name the output dataset GL Structures. Examine the field map. Merge will attempt to keep all fields. The fields that appear in both input files have a 2 by the field name. The other fields are found only in the Mount Rushmore dataset. These fields will contain data for the Mount Rushmore features and null values for the Hill City features. Run the tool. Remove the original Hill City structure and Mount Rushmore structure layers. Examine the table of the merged GL Structures feature class. Close the table and save the project. Add the Hill City Geology and Mount Rushmore Geology shapefiles from the MGIS Data Black Hills Downloads folder. Open the two tables and compare the fields. On a sheet of paper, write the field names in Hill City Geology that contain these two types of information. Repeat for Mount Rushmore Geology. In the Geoprocessing pane, clear and reopen the Merge tool. Set the input datasets to Hill City Geology and Mount Rushmore Geology. Name the output dataset Geology. Under Field Map, click the Formation Name field. Leave the Merge rule set to First. The box underneath indicates that this field gets its value from Mount Rushmore Geology. Click the Add New Source drop-down, which opens a pop-up field selector with the layers on the left and their fields on the right. In the pop-up, select Hill City Geology. Check the Formation 1 field and click Add Selected. On the left, click the unit field name. On the right, click Add New Source, select Hill City Geology, check the Formation _ field, and click Add Selected. Under Output Fields, click Formation _ and use the red X to remove it from the list. Remove all of the output fields except Formation Name and Unit. New Shape Lang and Shape Area fields will automatically be created for the output dataset. Run the tool. Open the table for geology and examine the fields. Scroll down and make sure that every feature has both a formation name and a symbol. Close the table. Remove the original Hill City Geology and Mount Rushmore Geology layers. Symbolize the geology layer with a unique values map based on the unit field. In the Geoprocessing pane, open the Dissolve tool. Set the input features to Geology. Name the output features Geology Dissolve. Set the Dissolve fields to Formation Name and Unit. Uncheck the box to create multi-part features. We want each polygon to remain separate in the output dataset. Run the tool. Create a unique values map for the Geology Dissolve layer. Based on the unit field. And examine the boundaries.